So the topic for today's discussion is life of a packet in a FortiGate firewall. So any of you aware of life of a packet in any other vendors like Palo Alto or Checkpoint? Anyone? I don't see any response in chat. Okay, so let's discuss the life of the packet in FortiGate firewall. So if you must have heard this term in Palo Alto, three-pass architecture or single-pass architecture, SP3. Yes, exactly, Vijay. So similar to other vendors, in FortiGate, we also have a parallel path processing, which which is able to handle most of the security processing at the same time. So in today's session, we will discuss like what are things FortiGate is capable of processing parallelly and how the packet processing varies with respect to hardware models, VM models, high-end and low-end. I will try to differentiate between these models and we'll discuss on that today. If you have any question, please feel free to drop the question in chat. And towards the end of the session, we will have an open mic. So let's start with this. Okay, this is better. So when the FortiGate receives a packet, the FortiGate firewall receives the packet, which is accepted by the FortiGate to be processed by the TCP IP stack. So some security checks will happen here. So whatever traffic, whatever packet, L2 packet we receive from our peer device, it can be a switch or router, which will be received in the FortiGate's NIC, and the NIC will accept the NIC will first check, the network interface will first check whether this packet uh, has a uh, valid checksum. I mean, on the L2 level, it will see if the checksum is valid. And also, they will check if the destination MAC address is a broadcast MAC or the MAC address of the NIC. Only if these two checks are valid, then the packet will be further processed by the firewall. And when I say further processed by the firewall, after confirming that, one moment. So at this stage, we will confirm if the MAC is valid, the destination MAC or the broadcast MAC is valid. And once that is valid, if the packet is validated, then the packet will be subjected to DOS policy. So in DOS policy, if we'll check if there is any DOS policy configured, and if in DOS, what we will check is we will not check for we will only check for packets that are valid for DOS. For example, TCP SYN flood, it's a valid DOS attack. So we don't have to go through the entire all the TCP communication. This DOS module have to only check the TCP SYN packets if it's checking if the firewall is configured for TCP SYN flood. So similarly, there are a lot of other DOS policies which can be configured. I will show it in the firewall. So only if those policies are configured, this DOS module will check if any DOS attack is happening in the firewall. Now, let's say there is no DOS attack happening, or if let's say the parameters matching. When I say parameters, there will be a limit which says like maybe 1,000 TCP SYN packets per second. If this parameter is not matching, then it is not considered as a DOS attack, and then the packet will be forwarded to the header integrity check. Now, this is an automatic check which doesn't need any configuration. For this integrity check, you don't have to make any configuration on the firewall. In fact, this header integrity check is something that happens in all the L3 device. So what are the things we will check in this header integrity? So we will check if the we will check if the packet is valid. It can be TCP or UDP. And we can also check for ICMP or GRE packets. So any packets, we will see if the packet is valid. When we say valid, we will see if the header is correct. So in all these protocols, there will be a field in the header which says which talks about the header length. So when we verify the validity of this packet, basically we will be validating the length of the header. What the length what we receive is same, whether it is same as the length listed in the header value. So we will compare this value and check if they are same. Only if the header length check is valid, then the packet will be processed in the next stage. So in the next stage, the firewall will check whether the whatever traffic which we receive, it's a IPsec VPN packet. So if it's a VPN packet, then the FortiGate have to perform a decryption. So FortiGate will check if it has. So in when we receive an IPsec packet, there will be a SA associated in all the ESP packets. So when we say ESP, we are talking about the data packets. So in the data packet, we will check what's the security association. And a firewall will then compare this, whatever SA it received in the packet, it will be compared against the list of SAs which the firewall maintains. So if the list is matching, then we can say there is an existing tunnel which is being built for this SA, and the firewall knows what keys it has to use to decrypt the packet. So it will check if there is an SA available in the table, and if an SA is available, then the firewall will proceed for a decryption. Now, at this stage, if it's a hardware model, they have this CP8 or CP9. These are called content processors. These are specialized hardwares which is available to improve the performance, VPN performance. When I say improve the VPN performance, these chips will help in decrypting the IPsec packets in a much higher rate. Now, once the decryption is done, once the decryption has been handled, whatever packet we are left is a plain text packet. Or we can say our actual data traffic after decryption. So this is what is left after the VPN decryption phase. Now, once this VPN decryption phase is completed, the same packet will be given to the next stage, that is the admission control. Now, when it comes to admission control, this is something which we have to configure on the firewall. So the first thing the firewall check is the quarantine list. So in firewall, there is a separate list that will be maintained depending on the configuration. So it will maintain a list of IP addresses which are in the quarantine list. So when we say quarantine list, it can be it can be a devices which are having a known if they are generating any malware packet. For example, let's say we have our network implemented, we have our Forti clients installed, and we also have Forti analyzer in our network. So based on the traffic logs coming from this client PC, Forti analyzer will run some check, and it will determine if the PC has any malware in it. Also, the firewall, when it processing the traffic, if it receives any malicious traffic coming from a specific PC, it based on the antivirus configuration, it can move that particular PC to a quarantine list. So once the PC get identified or moved into the quarantine list, no communication from that PC or towards that PC is allowed. So for this reason, let's say now we are receiving a packet on the firewall interface, and if it's coming to the admission control. So at this stage, the firewall will check the source and destination IP. if either the source or destination, if it matches with the quarantine list, then the communication towards this particular PC is not towards this PC or from this PC is not allowed. So firewall will start dropping the traffic here, saying like this destination or source is in the quarantine list. So if there is no quarantine list, if let's say the quarantine check is getting passed, then the firewall will check for the Forti telemetry. So Forti telemetry is where the Forti client will comes in. So it will check if the PC has a Forti client installed, and um, when I say Forti client, this is where our EMS solution comes in. So in FortiGate, in Fortinet, there is a EMS solution. So basically, this what the EMS will do is this EMS will install Forti client and it will manage those clients. So this will manage the Forti client. So using this Forti client, you can run a lot of checks on the PC. So this is not like a typical antivirus check. So you will check the PC configuration. When I say PC configuration, this Forti client can check the register entries of your PC, and only if the configured register entry matches with whatever register entry we have on the PC, based on this configuration, Forti client will start assigning tags to your PCs. So these are called security tags. So all the security tags will be this the rules. You will write the rules for the security tags in your EMS, and based on the registry value in your Forti client, your EMS will forward those tags to FortiGate. That is where the Forti telemetry comes in. So only if certain, let's say there is a tag which says uh, high critical. So which means I am assigning this tag to a PC which has, let's say, BitTorrent installed. So if BitTorrent is installed, then I will tag that PC saying that this is a high critical PC, and this information will be shared with the firewall. So when firewall starts receiving traffic from this particular PC, I can configure the firewall with a security policy to drop all connections that has the high critical tag. Now, let's say so, Arvind, this is not exactly ZTNA. These are EMS tags. ZTNA comes in a different scenario. We will discuss it later. These are not ZTNA tags. These are EMS tags coming from your Forti client. But Forti telemetry can also process your ZTNA tags, but again, it comes with a different set of configuration. Now, let's say in this Forti telemetry stage, there is no tags that is blocking our connection, and all the if let's say all the check goes through, then the firewall will proceed with user authentication. Now, this user authentication at this stage is active authentication. So I have to mention this because in the life of the packet, there is another place where one more authentication will happen. So this is the active authentication. So when I say active authentication, this is the captive portal which you enable on the firewall, and you will be enabling this on your interface. So yesterday, while going through the interface, we showed you an option for security check. Let me. Okay, lab is not set. Okay. Okay, I will show it to you again at the end of the session. So under your interface configuration, you have an option to enable security check, and you can enable captive portal there. So this is where the active authentication happens. So basically, if the captive portal is enabled on your source interface, so this is very important. This is not happening on the destination or egress interface. This happens on the ingress interface. So on your ingress interface, if you have the captive portal enabled, authentication enabled, then the user will be prompted for an authentication, and where the user will be redirected to a captive portal page where the user have to provide username and password. Only if the authentication gets success, then the traffic will be allowed further. If the authentication fails, then the traffic will be dropped here. So all communication from that particular IP will not be allowed. So this is the end of active admission control. Now, after admission control comes the actual firewall processing. The actual firewall processing happens at the kernel stage. Now, a kernel is where the FortiOS comes in. Now, it doesn't mean like admission control is not managed by FortiOS. Uh, till this part, we can say maybe the hardware will handle it, but again, OS has some play here. But after FortiOS, after kernel, it's the core FortiOS that is going to process the traffic. So this is where our policy inspection happens. So whatever security policy we configure, all the security policy evaluation will be done at the kernel level. So in order to determine the matching security policy, we have to match the traffic against the 5 tuples. So the tuple value which we have in the firewall is source IP, destination IP, then protocol, destination port, source or destination interface. So destination interface is not exactly a tuple because it is something identified after route lookup. So source interface. So these are the 5 tuples which is used by the security policy, which is used by the kernel to match your traffic against a security policy, because these are the exact information which is available in any packet which you receive in your firewall. So whatever packet you receive in your firewall, it will have a valid source IP address. It will definitely have a valid destination IP. It will have a protocol field which will talk whether it's a TCP or UDP traffic or ICMP traffic. It will also have a destination port, most likely a known port, and then it will also have a source interface where the traffic will be ingressed on the firewall. So using this 5 information, you can match against all the security policies you have configured in your firewall. So it doesn't matter how many policy you have, one of the policy will match against these 5 parameters. So once the policy is matched, firewall have to go through this 8 stages of management. So in what will happen in this 8 stage, we will look one at a time. So the first thing is the destination NAT. So the reason why the destination NAT happens at the first stage is because after destination NAT, your destination IP can change. So with DNAT, your IP might change. If the IP changes at this stage, your firewall will again go back to secure firewall processing once again, policy processing once again, because now your 5 tuple have changed. What I meant to say is, let's say you are receiving a packet with destination 10.1.1.1, and after translation, if it's being translated to 20.1.1.1, now your one of your tuple value, that is your destination IP, has changed. For this reason, now the packet will be sent to policy lookup once again. So that is the reason why the destination NAT is the first processing that happens in your policy lookup stage. So let's say now the destination NAT lookup has been done. And for those who are familiar with FortiGate, let me clarify this once again. So based on this 5 tuple values, you have matched with a specific policy. Let's say policy number 10. Now this policy number 10 has a DNAT configuration and you're matching it against this particular DNAT configuration. You're not matching with central NAT or any other policy in the world. You're matching it against an existing policy which you have matched using the first 5 tuples you have received. Now after DNAT, since the tuple value is again changing, you'll be going for another lookup, and at this stage you can either match with the same policy number 10 or you might match your traffic to some other policy. It depends on your configuration. Now once your destination NAT is done and then the second set of policy lookup is done, you will come for the before doing the policy lookup, you will come for the route lookup. Because you need to find the exit interface here. Now, based on your exit interface, your policy might again, your policy lookup might again change. Uh, what I meant is, for example, let's say if 10.1.1.1 is configured in port 1 of firewall, and using this information, you are matching with a specific policy. Now, after DNAT, you are changing your IP to 21.1.1. Maybe this IP is under port 2. So now your destination interface has also changed. So for this reason, you have to do one more route lookup on the firewall. Now, this route lookup involves your normal routing table, it involves your policy lookup, and it also involves your SD-WAN rules. So based on all these three categories, you will determine what is your exit interface, and based on the exit interface and all the existing 5 tuple values, you will be matching against your final policy. Now, I will show this in lab when we discuss about the flow debug. We will see the stages it goes through to process a policy. So in the logs, we can clearly see the traffic going through multiple policies to match against one final policy. So we will see the process repeating again and again. So at that time, maybe you will get a better clarity here. So once the policy lookup is done, a session will be maintained by the session will be created by the firewall. So once the security policy has been identified, firewall will start building the session. So at this stage, if it's an existing packet, firewall will check if there is an existing entry in the session table. If let's say if it's a SYN packet, so there is no way a firewall has an existing session for a SYN packet. So firewall will treat it as a new session, and firewall will go to the session building process. In TCP we have different flags, right? So I believe everyone is aware about the flags in TCP. So we have some flags which are termed as control flags. For example, SYN, PIN, and reset. These are the control flags in TCP. Using these flags, you can control a session on a firewall. For example, when you receive a SYN packet, you will be creating a new session. If you receive a FIN or reset, you'll be closing an existing session. So these are called control packets. So based on what packet you receive, this session inspection or your session management will happen. If you receive a SYN packet, you will perform your session creation or you will perform your session matching. If you receive a FIN or reset packet, you will do a session management where you will delete your existing session. Now, this is the stage where your stateful inspection will also happen. When we say stateful inspection, what we mean is, let's say you have a traffic coming from TCP, uh, coming from TCP source port 8080 going towards destination port 80. Uh, let's say this comes from port 1 and goes towards port 2. This is for outgoing direction. The in the firewall, you will maintain another entry in your session, which will allow your reverse connection and which will have a source port of 80, destination port of 8080. So this is what we mean by stateful inspection. So in short, for stateful inspection, you don't have to create two security policies for each direction. You will create one security policy in one direction, and firewall, by analyzing the IP addresses, port numbers, interface where it receives the traffic, it will create a return traffic flow. A return it will create a session for your return traffic flow. So for this return traffic, you don't have to create a separate policy to allow this connection. So in short, at this stage, you will create your session, you will maintain your session, and also you will match your traffic against an existing session. Now, along with this, now this session management which we talked about at this stage 3, this is only for your normal traffic. Now, let's say there is a traffic which cannot be built. Uh, how do I explain this? Okay, so if it's a normal HTTP or HTTPS traffic, you can look at your TCP source port and destination port, and you can identify at on which destination port your return traffic will come in. That's easy for us because this information is available in your header. Now let's say instead of HTTP, it's a TCP session. Sorry, it's an FTP session. So in FTP, especially with active FTP, we have our control connection and your data connection. Now, initially, when the handshake happens, all the communication will happen with your control connection. Now, at this stage, firewall, the communication will happen in port number 21, if I'm not wrong. So firewall will build a session by looking at the source IP, destination IP, and when it comes to TCP port, it will be looking at the port number 21. But when the data connection comes in, the data connection can be in a random port, let's say 45,000. Now, let me explain this in detail because this is an important step to adjust to understand the session helper. So let's say I have a firewall and let's say I have a PC 10.1, which is trying to communicate with 20.1. Now, let's say this is an FTP connection, which is happening on port 21. Now, I know the destination port is port 21. So based on the IP address, port number, and the ingress interface, firewall will build a session in its table, and this TCP three-way handshake will happen for this control connection. Now, once the control connection is completed, the client who is going to initiate the data transfer will initiate the connection on a completely different port, which is a random port, let's say 45,000. Now, in firewall, you cannot create a security policy to allow any connection coming from this IP address. You have to define your services to make it more secure or more specific. Now, we don't know at what port number the client machine is going to initiate your data connection. So this is where your session helper comes in. So basically what the session helper will do is it will not only process your layer 4 information to actually build the session, when the firewall process your FTP connection, it will also read your layer 7 headers. So in layer 7 headers, during your negotiation, control channel negotiation, there will be one field in your header which says what in which TCP port the data is gonna come in. So this information will be learned by your firewall by inspecting your layer 7 header. And once the firewall identifies this information, firewall will create a different set of session, which is called expectation sessions. Now, this is not your normal session. This is expectation session. And this expectation sessions will be short-lived. It will be available in the firewall only for a 5 seconds period. After 5 seconds, the session will be timed out. So within the 5 second, if your FTP server responds back with its data connection, this data connection will be allowed without a security policy in your firewall. Now, the same logic applies for a lot of other protocols. For example, if you're aware about SIP or your voice traffic, the same thing happens. Your SIP will only take care of your control channel connection. It will only negotiate on which protocol it have to use to encode your traffic. Where is your calling party? Where is your caller party? Where is your uh, service? I mean your call handling service. Only those information will be available in your SIP headers. Your actual voice or video traffic, they will be encoded in a different protocol. So this and the actual voice traffic can come in some random port. So firewall will look into your SIP header. It will read the layer 7 data, and then it will build a expectation session based on the information it identifies in our layer 7 header. So this is what the session helper will do. I hope this point is clear. If there's any question, we can discuss this once again on this topic. So once the session is created, then the firewall will go for user authentication. Now, this authentication is passive authentication. Now, it can also be active in a sense where, let's say you have not configured captive portal and you have only configured your user authentication in your security policy. So, for example, in your policy, if you specify any group information or your user information, then firewall will go for authentication here. So if the firewall is configured for passive authentication, firewall will check your LDAP server to see if you are a valid user. If not, firewall will prompt you with the authentication page where you have to provide your username or password. So once the authentication succeeds, then the firewall will check if device identification is enabled. Firewall will see if your device is allowed in your network, and this is something which you will configure in your firewall. For example, MAC address based objects. In firewall, we have an option to create MAC address based security objects. So if you have configured them in your security policy, then firewall will check if your device is allowed. Now, let's say your device is allowed to communicate at this stage, and then the firewall will go for SSL VPN. Now, the reason why it goes for SSL VPN check in your policy is because SSL VPN is treated as a special management traffic. Because the reason why it's treated as special management traffic is because this is the to the box traffic, because SSL VPN is being hosted on the firewall in one of its virtual interface. So it's a to the box traffic which is considered as a management traffic. Now, after SSL VPN lookup, if it matches with any of your portal, based on your portal configuration, your exit interface will be identified. So once the VPN traffic get terminated on the firewall, after decrypting your SSL VPN, your actual header, the plain text traffic can have a different set of source and IP address, source and destination IP address. If it finds a different set of source and destination IP address, then the traffic has to be repeated through all this process once again. So for example, let's say you are connecting to SSL VPN. So when you connect to SSL VPN, let's say your source IP address, let me explain this here. Let's say on the firewall, you have your port 1, which is configured with IP address 10.1.1.1, port 4443 for your SSL VPN. Now, any client PC, let's say coming from internet, which has an IP address 80.1.1.1, will establish a tunnel with your port 1. Now, let's say uh, there is a server behind our network, which is in the IP address 20.1. And this PC is trying to access the server. Okay, so the header will be created with, let's say, the IP address is, the source is 80.1.1 and the destination is 20.1.1. Now this packet will be encapsulated in another header which has a source IP address 80.1.1 and the destination IP address 10.1.1.1. Now, I'm just giving this as an example, but in real time, your IP, the source IP will not be the same here because the your inside header will have the source IP address of your VPN adapter. I'm just giving this as an example here. So once the IP address is once the packet, the SSL VPN packet is created, this is an encrypted packet. This encrypted packet will be sent to your firewall. Firewall will process it uh, to the kernel, and it will come to this stage where it will treat it for SSL VPN. Now, at this stage, after decryption, firewall will look into your actual header, that is your inside header, and your inside header will say the traffic is destined to 20111. So now your header, your 5 tuples have changed. So for this reason, firewall will go through the security policy lookup once again to identify if there is another policy configured to allow this connection. Now let's say if it's not an SSL VPN traffic, if it's a normal pass-through traffic, then the firewall will also check if it's a local management traffic. When we say local management traffic, firewall will check if the traffic is destined to the firewall for any service. For example, any of your LDAP service or your GUI or CLA access to your firewall. Now the way this local management traffic check is done is by using a local in policy. So many of you must be aware of firewall policy, security policy, but there is another policy which is hidden on the firewall, which is called as local in policy. Now, using this local in policy, you will be able to control what traffic to the firewall is allowed. I mean, you can control to the box traffic by configuring this local in security policy. So it's also a kind of security policy, but it is hidden by default. We have to enable that feature to check this. Probably in one of the class, we will check this in the firewall. I hope till this point, the processing is clear for everyone. We will come back to any questions on this later. Now, let's say your security policy check is done. It's not that you have completed your policy check at this stage. You have only identified a basic policy match here. Now, after your basic policy match, now you're going for UTM inspection, UTM or next generation processing. Now, this is where your profiles, all the security profiles which we configure on the firewall will come in. Oh, excuse me for a minute, guys. Okay. So at this stage comes our UTM inspection. So whatever UTM profiles which we configure in our firewall policy, they will be checked at this stage. So this is where our single pass architecture comes in. So again, the single pass architecture, it depends on the inspection mode, whether the policy is configured in flow-based mode or proxy-based mode. So depending on that, the inspection will change. For example, if the firewall is configured in flow-based mode, let me write it here. If the policy is configured for flow-based inspection, then that all the traffic that is being processed by the firewall will be processed in real time. In a sense, firewall is not going to buffer your content and then inspect. Let me give a short context here. So if the difference between flow-based and proxy-based in the FortiGate firewall is in proxy-based, whatever packet that comes through the firewall, it will be stored in the memory for a short duration, and then the packet will be inspected. For example, if it's a PDF file, the entire PDF file, if it's a 5 MB file, the entire 5 MB file will be cached on the firewall for inspection. Only if the file is cleared, if there is no malicious traffic or any malware in it, then the actual file will be sent to the NPC, the client. Uh, to be more precise, what happens is, let's say your 5 MB file is divided into 5 chunks, for example. Let's say it's divided into 5 chunks. Firewall will receive the first chunk. It will store it in write it in its memory, and it will send the first chunk to the end client. The second chunk again it will store in its memory and it will forward it to the end client. Similarly, third and fourth will be stored in the memory and will be similarly forwarded to the end client. But the last chunk, the fifth chunk, it will be stored in the memory, but it will not forward it to the end client. Instead, it will perform the complete inspection. It will do all the UTM inspection. And once the UTM inspection says this packet is free of malware, then the last chunk is forwarded to the end client. If the last chunk is, let's say for some reason, if any malware is identified in this PDF file, and if the UTM inspection is failing, at that stage, it will not forward this last chunk. Instead, firewall will send a reset packet. Now, without this last chunk, the end client won't be able to reassemble the PDF file, and the file will be corrupted. It will be a corrupted file. Now, with a corrupted file, the actual malware will not exist in the PC. The malware file will not be complete and it won't execute. Now, second time, let's say another user is trying to access the same PDF file. Another user who is trying to access the same PDF file. Now, firewall has the hash value maintained for this PDF file. So it will not go through the entire file inspection. It will directly match the file against the hash and it will block the connection. No, it will not forward a single chunk to the NPC. This is how the proxy mode works. But on the other hand, in flow-based mode, firewall has a capability to inspect the traffic in real time, which means it don't have to write anything to its memory. The packets can be inspected on the fly. But during this inspection, if in any of the packets, if the firewall identifies any malware, it will directly inject a reset and it will close the connection. So this is how this is a different short brief difference between flow-based and proxy-based inspection in firewall. Now, in this context, when it comes to UTM inspection, with flow-based, firewall will use the TFA matching. So what the EFI matching is nothing but direct filter approach. So basically, uh, there are a filter. When I say filter, it's nothing but regular expressions. So these are regular expressions. These regular expressions are created by Fortinet solutions, and they will be pushed to your firewall to match it against your traffic. So basically, these regular expressions are going to match to your layer 7 header. And if there is if they based on the information available with Fortinet, they will know they know how a malware packet will look like, what because they have a separate team to analyze and create all these regex, and there's an automated process available with them. So based on this, the Fortinet will keep on learning all these threat patterns, and they will push updates to your firewall using content update. So if any of your packet that matches with this regex, which is a known malware, then the packet will be the connection will be reset, and the traffic will be dropped. But on the other hand, if it's a UTM inspection, for proxy-based mode, the entire packet has to be stored and decrypted if needed, and then scanned for inspection. So another important thing, IPS engine on the firewall will handle your flow-based inspection, and WAD on your firewall will handle your proxy-based inspection. So proxy-based inspection is mostly applied for your VoIP profiles, I mean your SIP traffic, then your DLP, email filtering, web filtering, antivirus filtering. So for these functionalities, WAD will be used. But for application control or your IPS inspection, it can be done in your flow-based mode. It doesn't matter for application control. It doesn't matter whether it's flow-based or proxy-based. Anyways, it's going to be handled by your IPS engine. And the way the firewall identifies a particular application is just by matching the regular expression. For example, let's say you have Skype traffic. Now, Skype traffic, it has a pattern. Uh, So just by looking at the header, we will be able to identify that this is a traffic going towards Skype. So firewall will just simply match a regex against the packet, which will say Skype, and then it will identify the application. It's a complex process which is not visible for us on the GUI, but this is what happens in the backend. Now, along with this flow-based and proxy-based inspection, if there is any explicit web proxy configured, then that inspection will also happen here. So explicit proxy I will cover in another session. I don't want to confuse it here, so I will come back for this. Now, once with all this UTM inspection, let's say the packet is allowed. There is no malware. The packet is allowed to forward. Then the traffic will be given to the kernel again to be forwarded out. So So Aravind, deep inspection to be enabled, it depends on the profile which we apply. We will discuss this later. So once the UTM inspection is done, then the packet will be again sent to the kernel for inspection. Sorry, kernel to be forwarded out. So at this stage, um, you will find the egress interface. So firewall will maintain a table cache where it maintains the IP and MAC, and those information will be populated, and a packet will be created. And at the same time, if a source NAT has to be performed, if the source IP of the interface of the packet has to be changed, that operation will also be done at this stage. Now, after the source NAT, and based on the forwarding interface, if the forwarding interface is a VPN interface, IPsec VPN interface, then the packet will be given to IPsec encryption. If it is not a VPN interface, then this stage will be skipped. And again, IPS encryption will be handled by the CP8 or CP content process, because these are specialized hardware which is helpful to speed up the inspection. Sorry, speed up the encryption. So once this is done, if the firewall will check if there is any QoS configured. QoS is always applied on the egress, not on the ingress. So if a QoS is configured, then the appropriate shaping profiles will be applied. If there is no QoS configured, then the firewall will check if there is any WAN optimization being configured. So WAN optimization is another feature available in the firewall. Let me give a short description about WAN optimization. So so WAN optimization will only work on hardware models which has a dedicated disk available. It will not work in every model. So please keep this in mind. Let's say we have two firewalls, firewall 1 and firewall 2. And we have a server behind this firewall 1, which is having some PDF file, and a client. We have multiple clients behind this PC who is going to access this PDF file. Now, if WAN opt or WAN optimization is enabled on the firewall, there is a client and server a relationship being formed between these two firewalls based on the configuration. Let's say now this firewall is configured as a cache server. So what will happen is, let's say this PCA tries to access this file. Okay, so the first time it will connect to the server, it will download this file. When the PC downloads the file, the firewall will store this file in its own cache. I mean, in the disk, this file will be saved. Now, let's say this firewall one is in US. The firewall one is in US, and the firewall two is, let's say, in India. Now, the maybe the you are going through a link where you have a latency, high latency, and you were able to download this file. Let's say this is a 10 MB file, and you are able to download this file after 15 minutes. For example, let's consider this. Now, the second time when this user B tries to access the same file, now the request will be sent to the firewall. Firewall will have to forward it, but firewall will look by just by looking at the header, it knows that this user is trying to access the same file which it has in its disk, and firewall will directly send the file to this PC. So this will take maybe 1 milliseconds. So this is what the WAN opt is. So again, it's not easy to enable this. You have to enable this only if your firewall is capable of this feature. It needs a physical hard disk on the firewall. And once you enable this feature, you won't be able to store any log on the firewall unless you have two disks. For example, let's say we have a model which has disk 1 and disk 2. Disk 1 is used to store logs, and disk 2 is used for WAN opt. Or you can use both disk for WAN opt. So depending on your configuration, this will be selected. And yeah, there are certain content types which you can store in disk. Only those are supported. So if WAN opt is configured, then it will process it for WAN opt. If WAN opt is not, then it will skip. And then the packet will be given for TCP IP stack, where the your L3 and L2 headers will be created. And after L2, L3 header creation, your packet will be placed on your NIC and it will be forwarded out. So this is what will happen on a packet which doesn't have offload. When I say it doesn't have offload, this is what happens in a firewall in any VM instance, or in a firewall in a firewall where offloading is disabled. So, one moment. So I'm unmuting you all, so please be mindful of your mic. If you have any questions till this point, please let me know. We can discuss it again. If you want me to explain any particular step once again, I can explain it now.
Help is different flow based on the proxy based. So in what scenario we apply proxy based inspection?
Okay, Ganesh, the scenario we will come back when we discuss UTM profiles. We have a separate class for UTM profiles. We will discuss it there.
Want to just want to submit. So what is the purpose of proxy based? Because most of the policies we use flow based inspection as proxy based inspection.
Okay, so
Some uses.
let's say you are performing web filtering, for example. You are performing web filtering, and in web filtering, you have an option to allow only emails from your specific domain. Emails from your domain will be allowed. Now, for this function to work, firewall have to rewrite your L7 header. Rewrite your L7 header in a way firewall will insert a specific header in your HTTP traffic, in your HTTP header. I don't remember the name exactly, but there is a header it will insert in your HTTP. Now, for this function to work, the policy has to be in proxy mode. If you are not using this function, if you are only using your web filtering to see whether the traffic is going towards YouTube or Facebook, you don't need proxy mode. You can do this in flow mode. So this is one example.
Using a security profile in some scenarios we can suggest proxy.
Yes, exactly. Yes.
So not every security profile is required proxy.
No, not for every security profiles. So any other questions regarding this stages of processing?
So, like the symmetric and asymmetric route, so FortiGate will not understand. We'll get to know how the like if it is a asymmetric route, will
Okay.
FortiGate understand?
So firewall will be able to identify symmetric and asymmetric at this point when it manages the session. So, for example, on the firewall, if the first packet which I receive is SYN, then it's fine. It's a symmetric packet. So I'll be able to process it, and I am expecting a SYNAC back. Now, for some reason, let's say you have two firewalls in your network, okay? Two firewalls in your network, which is maybe your deployment is something that way, and your SYNAC flows to your second firewall or in a different path, okay? Your SYNAC flows through a different path. Your firewall one is not has not received your SYNAC packet, but instead it receives your ACK packet. Now this is an asymmetric traffic flow. So in this scenario, firewall is not receiving all the packets, so it won't be able to it won't be able to do all the security inspections in a good way. I mean, if it's not receiving all the packets, if it's not receiving the entire context, it won't be able to understand the traffic, and it won't be able to inspect them properly. For this reason, by default, asymmetric traffic is disabled in the firewall. So the moment the firewall receives an ACK without a SYNAC, firewall will start dropping the connection. So you have to, if you want to allow this, we have to enable this from CLI. Did I answer your question, Aravind?
Yes, sir, got it.
Okay.
Sir, in this, like in Palo Alto 6 tuple, so here 5 tuple, so it doesn't look at the zones.
No,
So,
in FortiGate firewall, zone is just used in SD1 configuration. And for you to simplify your policy configuration, you can club together multiple interfaces in a zone and you can refer them in a policy. That's the only purpose of zone in FortiGate. In FortiGate, zone is not looked at as a tuple value.
Oh.
Yeah. So if there
So
is no
this
other,
content processing 8
yes.
and content processing 9 on the IPsec VPN decryption.
Uh-huh.
Part. So the I didn't get that part. Can you
Okay.
explain?
Okay. It's very simple. It's just a hardware module. It's a hardware chip which is available to speed up your inspection. Now, if it's a VPN model, there is no CP8 or CP9. But while explaining this, I explained two scenarios here. One is VM and the other is your hardware with offload disabled. So these are the two scenarios which will match this packet flow. So CP8 and CP9, CP8 or CP9, it's not both. One of the chip will be available. So these are specialized hardwares which is useful for to speed up the processing. So these are ASIC chips.
Okay.
Yeah.
So this is not available on the VM version. So you cannot. It's only on the hardware model.
Yes.
Okay.
CP8 or CP9 is only available on hardwares, not on EMs.
VM. Oh.
Yeah. So if there is no question in this, let's move on to the next stage. Again, I want to repeat this. So only if you understand this, the next ones will be easy because I'll be skipping certain stages in the next topics.
Sir, that signature, what do you call it? Regex pattern match that you explained here.
Uh-huh.
So it is.
Yes, please go on.
It's similar to the signature based matching, sir, like IPS.
Yes, this is what the signature matching is. This regex is the signature matching.
Okay, sir. Okay.
So IPS engine will process this. So for any application or known malware, they have their own signature. So those signatures are developed as a regular expression. So
So one more thing. So this IPS can
mhm.
only do signature based matching. Can it not do anomaly based matching, sir?
Anomaly also will be done by IPS.
Okay.
When we say anomaly, it's just reading the for anomaly to match, it have to match with the regular expression. So for example, if you modify a packet header to make it a malicious traffic, the pattern, the regular expression pattern of that packet changes. So that will be identified by IPS engine.
Okay. Okay. Got it.
Yeah. So any other questions for others? If not, then I can move to the next topic. I will take that as a S and we'll move to the next one. Now this is the flow for NP6 Lite, okay, NP6 or NP7 Lite. So NPX Lite. So this NPX Lite is available in lower end models. So typically on a 30 or your 60F, you will see this Lite models. So I'm only explaining the difference in terms of what this Lite will do. Now I'm not going through the entire packet flow. Okay. So for NP6 Lite, all these stages will be the same. Only during the ingress, when the packet is being actually received, there is a slight change in the way the packet is being processed. Okay, so only that I'm going to discuss in this. So with NP6 Lite, now there is an additional capability which comes in, that is your ACL. So let's say let's say there is no ACL, okay, and you're receiving a lot of traffic. All the traffic have to flow through all these stages, and then it have to reach the kernel where the firewall CPU has to come in and then do the packet processing. So sometimes with the load being high on the firewall, this can be expensive. Your CPU can run on a high load. To avoid this, you can configure ACL on the NP chip. Basically, on the hardware model, you will have your front panel. Let's say there's a front panel, and behind the front panel, you will be having your NPX and then your CPU. So all traffic to CPU will pass through your NPX. So in order to protect your CPU, we have the capability to create an ACL in your NPX, and using this ACL list, you can drop certain traffic so that you don't have to send them to CPU to build the session and process it. So this is the one advantage we have with NPX Lite. Now, other than that, once the traffic is offloaded, when I say offloaded, let's say you receive the SYN packet. I should explain the offloading concept also here. Let me run a quick brief on that. So basically, what is offloading? So let's say we have our firewall CPU and then our NP chip and our front panel interface. Let's say this is port 1 and port 2. So what is offloading? So let's discuss that. Let's say firewall receives a packet on its port 1 and this is a SYN packet. So the SYN packet will be sent to your CPU through your NP. So this packet will flow through your NP, and when the packet comes to NP, NP will check what is the flag available in the packet. So basically, NP will check for control packets, that is your SYN, FIN, and reset. So firewall, the NP will check, will see if it's a SYN packet. So it's a control packet, and there is no session being built on the NP. There is even if it tries to match, there will be no session in the NP. So NP will forward this to CPU. Now CPU will start processing. When I say start processing, it will go through the policy lookup stage and session building stage. So once it goes through the policy lookup, session building, UTM inspection, once everything is completed, uh, the CPU will also identify based on because when it does the policy lookup, it also does the route lookup. So at this stage, CPU will know what is the egress interface, and CPU will forward it out of your port 2. Now, when the CPU forwards the traffic out of port 2, the CPU will also create an instruction set. Let's say it will also create an instruction set, and this instruction set will be forwarded to NP. So NP will save this instruction set in its memory. So basically, what the instruction set will say is any connection coming from, let's say this is client A, this is client B, connecting towards port 8080 towards port 80. Let's consider this for an example. So this instruction set will say, let me write it here. It will say connection coming from PCEA with source port 8080 going towards B with port 80 coming ingress on interface port 1, send it to port 2. Sorry, excuse me, my writing. If it says traffic ingress on port 1, then forward it to port 2. This is what the instruction set says. Now, along with this, now this discussion is only hypothetical. This is not exactly what will happen when the packet flows. This is just for understanding. Okay. Now let's say now this instruction set is being installed in your NP. Now your return traffic, let's say your return traffic, which is SYNAC, comes from your server, your client PC. Now this SYNAC will be received on port 2, and it will be sent to your NP. Now there is a good chance NP will don't know anything about this return traffic, because if it tries to match in its instruction set, there is no information that is matching this. There is only an information which says connection coming from A 8080 B 80, send it to from port 1. There is only instruction for one direction. So the NP will again forward it to your CPU to process the session. So CPU will process the session, and then it will update another instruction set which says connection coming from B on port 80 going towards A 8080. If it being received on port 2, forward it to port 1. Now this instruction set will also be updated in your NP. Now let's say your third packet in your connection, that is your ACK packet, comes in. This ACK packet will now be offloaded in a way. The ACK will be given to NP. NP will check its instruction set. It has an instruction matching here. So it knows where to forward port to. It will directly forward the packet out. This is what we call as offload. Now the traffic is not going to your CPU. It's being offloaded. Now let's say after some time, there is another control packet. Let's say the session is about to be closed. You are receiving another control packet. Let's say it's a fin packet. Now this fin packet will be sent to your NP. NP will read the packet, and it understands it's a control packet. So it will forward it again to your CPU. So CPU will close the session, whatever session. Again, one more thing. This instruction set is not your session table. It's different. It's a local table maintained in your NP. Your actual session will be maintained in your CPU. So your once the CPU receives this fin packet, CPU will close your session, and it will also update your NP saying that you can remove this connection because this is where you received your fin. So this entry will be removed from your NPU, and the packet will be forwarded out. Now for this fin, there will be an ACK. So there'll be a FINAC. So that FINAC packet, once it's been received by your NP, let me write it. Now once we receive the FINAC packet, this FINAC is again a control packet, will be sent to your NPU. NP will again forward it to CPU because it's a control packet. Now CPU will send another instruction to close this connection, this instruction set. It will delete this instruction, and then it will forward the packet out of this port 2. So this is how CPU will maintain a session, and how the traffic will be offloaded. Now, this same capability, same operation can also be done by the NP6 Lite. But along with the offloading, the one another advantage it has, it's the ability to create ACL. So when the initial packet comes in, Ferrell will directly check it against an ACL. If there is any ACL configured to drop the connection, packet will be dropped right here. It won't go through any other processing. Rest of all the stages are same, like what we discussed earlier. Now, with this, there's one more scenario I wanted to discuss. Let's say the firewall has an N turbo. let's say firewall has an N turbo. N turbo is nothing but the uh, it's a fast processing available just to process your flow-based inspection. So if you have a policy configured for a flow-based inspection, after your the initial stages will remain the same. So let's say let's say you receive the packet, your initial TCP stack check is done, then it will go for automated the automatic integrity check if this is cleared, and if it will goes for decryption, IPsec decryption. Now, after decryption, it will look at the plain text traffic, and that plain text traffic will be given for your policy inspection. Let me bring up that image for you to refer. So after your decryption, the traffic will go for admission control, and then it will come for your policy inspection. Now, at this stage, if it goes through a flow-based UTM inspection, then the IPS engine will handle the traffic. Now, this IPS engine will take over the signature matching, and it will use a single pass rule. Now, in single pass, it will check multiple profiles at the same time. So, for example, what are the things it will check is the IPS engine can process your IPS signature matching, then your application control or app ID functionality, then your web filtering, then your DLP, and your botnet check. If any destination goes to a known botnet, that can also be checked, and then your AV check. So all this will be done by the IPS simultaneously. That is what we refer as a single pass rule matching. Now, one there's one difference. So let's say this 5 checks can be done without any catching. So the packets are like processed in real time. There is no packet catching, but only for AV inspection, the packet will be catched. So the way it catches the packet is um, when the packets are being sent to all these inspections, same time a copy of the file will be given for AV inspection, and AV will process it simultaneously, but it will be different. It's not now in this stage. At this stage, scan unity can also come in. So there'll be an application running in the firewall scan unity. So this will also come in to process your antivirus inspection. Though it is the IPS engine who is performing all this, just to assist the IPS engine, a scan unit engine will also come in to check your AV files. So once the verdict from all the stage is to allow the connection, now the traffic will be sent back for encryption if needed, and again the traffic will go through the same path for processing. Now this is with nturbo. Now you must have a question. So what will happen at this IPS engine? So now that is what we will discuss in our next topic. So what will happen at IPS? So again, we have skipped some of the stages here. So let's say the packet is being received by the firewall. All the initial checks has been done till this stage, and the packet is given to our IPS engine. Okay, so this is where the packet enters our IPS engine. Now to reiterate, we are only focusing on this stage now. Okay, so packet has gone through integrity check, decryption, everything, and then came to the IPS engine. So in IPS engine, first we have the protocol decoders. So protocol decoders will take care of any L2, L3, and L4 traffic. Uh, so basically, decoders are a way, these are set of rules to understand the headers. So basically, it will read through the header, it will understand what kind of traffic it is being carried in. And after this header processing, the firewall or the IPS engine will check whether the traffic is an SSL encrypted traffic. If it's a SSL VPN traffic, if it's an IPsec traffic, it will check the if it's an IPsec traffic, the IPsec decryption has happened even before this IPS engine stage. If you remember the previous diagram, the IPsec decryption has happened even before the packet entering the IPS stage. So we don't have to be worried about the IPsec decryption. But if it's a SSL encrypted packet, then the packet will be sent to it will check if it's if it's an SSL packet, it will check if it's exempted from decryption. So by default, as per GDPR compliance, there are certain traffic we cannot decrypt. Any firewalls cannot decrypt, but we can manually override it. But by default, firewalls are configured not to decrypt certain kind of traffic. For example, WhatsApp chat is by default not decrypted by firewall, but we can create an exemption and definitely we will be able to decrypt it. But if there is an exempt list, it will check if the packet is exempted. If yes, then the packet will be directly given for UTM inspection, where it will go through the UTM profiles. If it's not SSL exempted, if it's okay for decryption, then the packets will be given to be decrypted. Again, the decryption will be carried out by CP8 or CP9. So CP8 or CP9 will process the traffic, and again, if the traffic is to be mirrored, if the SSL mirroring is configured, a copy of the packet will be sent to your SSL mirroring server. If not, the decrypted traffic will be again given to transport decoders. This is our layer 7 decoders. So in layer 7, again, you will check the traffic against your HTTP, FTP, whichever protocol port number has been identified based on the TCP destination port, then the protocols will be decoded. So after protocol decoder is done, then the packet will be given for file decode. So file decode is where your file type is inspected and an action can be taken. So this is where during the file decode, your file will be buffered for the flow AV to be inspected. So this is where scan unity comes in to inspect the traffic, while the same packet goes through your single pass architecture to go through other levels of checking. That is IPS signature, application control, or your botnet check or URL filtering check. While all these checks are being done parallelly, your files are given to Flow AV to perform the AV inspection. Now, if the AV inspection is successful and if the UTM inspection, this is your UTM inspection, if this is also successful, then based on the action allowed or denied, the packet will be allowed. And if it again has to be encoded, if we have decrypted here, then we have to encode it again at this stage. So packet will be encoded and will be sent out. So this is how the IPS engine will handle the traffic. It has so IPS engine is nothing but a protocol decoder, and when it decodes the protocol and the files, it will match it against your regex. Or in other terms, this is the signature matching. Now, how is this different from our proxy-based inspection? So let's discuss that in our next topic. Any questions? So Arvind has a question, quick protocol traffic. So Arvind, if your question is how the quick protocol will be handled, quick protocol, it works in a completely different way. So firewall will be able to identify it as a quick, but It
Not be
won't
able to
be
inspect, right, sir?
uh in order to inspect uh no, inspection will not happen for quick. That is the reason why we will disable quick in firewall. Quick is a proprietary protocol coming from Google Chrome. Not other browsers will use it. Only Google Chrome is using it now. It's a proprietary protocol of Google. So we will block the quick during the initial negotiation. Only if the quick is allowed in the network, the browser will switch to quick. So if we block quick, then the protocol will not be allowed and the traffic will switch back to HTTP, HTTPS on
Sir,
port
this
443.
IPS engine will work with the license partners. In case if we don't have a IPS license, so this process will not happen.
Uh, for the IPS engine to function, you don't want a license. But
Okay.
for the firewall to get the updates, to get this regular expression signatures, you need license.
Okay. So it will only go with the default signatures that is there in the firewall. It cannot go to the cloud and see what is the updated signature.
If you see the default signatures, it will be 0000. The database will be empty. But
Okay.
you will see the options to configure them, but the database will be empty. It don't have anything to match against.
Okay.
Yeah, only if it has a license, it will be able to download this database from FortiGuard.
Sir, in terms of app ID inspection, there's no application. FortiGate will not be able to identify which application.
It happens here at the transport decoder.
Okay.
Yeah.
So we can also add a custom application signature, sir.
Yes, we can create. We can also configure our own custom application signature, which is again a regular expression pattern which we have to provide to the firewall. Okay, now let's take a look at the proxy.
Sir, this diagram is available online, sir. Like
Yes, I
the
will
life
share a
of the.
document with you. Yes.
Sir, this offloaded traffic, can it be captured over sniffer, sir, like packet capture?
No, we won't be able to. I will explain this next, not Aravind. Let me finish this and then we will come back to that. Okay, so in proxy mode, if you remember, I explained it over here somewhere. Okay, so even though the traffic is proxy based, given for proxy based inspection, it will still go through your IPS engine because your IPS engine still handles your application identification or IPS signature matching. For this purpose, even though your traffic is for proxy, it will go through your IPS engine. So that is what being shown here. So the first, your traffic will go through, even if you want your proxy-based inspection to happen, your traffic will first go through your IPS engine where the application control takes place. Botnet check and SSL inspection will happen along with your IPS signature matching. After this, the traffic will again come for proxy-based inspection where you will check whether the packet can be decrypted. If it's a whether it's a decrypted traffic. If it's a decrypted traffic, then okay, sorry, it will check whether we are allowed to decrypt. If we are allowed, then it will perform the decryption. If no, without decryption, it will check these functions. So these are the same functions which will be done by your IPS. Oh, one moment. Sorry, it will check if the packet is decrypted. And if yes, if needed to be decrypted, it can process with the decryption. If no, it will perform these checks without decryption. So again, this is where the IPS will come in and it will perform this check, and then the packet will be sent out. If it can be decrypted. Decrypted traffic, again, decryption will be handled by your IPS engine, but WAD will also play a role here. But again, it's internal processing. WAD and IPS engine will communicate, and then they will handle this decryption. And after decryption, this will go through your these checks. Now, the same checks can be performed in your IPS engine also without decryption. But the only difference is certain functionality, which I said. For example, in web filtering, if you want to insert your HTTP header, you want your traffic to be decrypted. Uh, for example, DLP, if you are sending a file in an encrypted message, encrypted email, then you won't be able to identify it using your IPS engine. If it's an encrypted email, definitely you want proxy to be enabled. But if it's a non-encrypted email, then if it's a non-encrypted email, then your IPS engine will be able to handle it. For this, you can go with flow-based also. You don't have to configure proxy-based. So someone asked a question in which scenario you will configure flow or proxy. So this is another example. Depending on your traffic pattern, you will decide whether to go with flow or proxy. Similarly, for VoIP inspection, some vendors will encrypt your VoIP traffic. Not everyone, but some vendors will encrypt your VoIP traffic. So if your VoIP traffic is encrypted, then definitely we need decryption. Antivirus only if we want to inspect an encrypted connection, we need to send it through proxy. If it's an unencrypted connection, IPS will be able to handle. After this inspection, if the connection is allowed, then the packet will be encrypted back and sent out. So this is the flow for proxy. But the only difference here is along with IPS, WAD will also come in, but the functionalities are like combined. That is all the topic I have for now. But okay, one more topic. This is about explicit proxy. So why do we use explicit proxy? So the answer lies here because if you are decrypting all your traffic in your firewall, then the CPU will spike like anything. Just decrypt 25 to 30% of your users' traffic, your CPU will be like 70 to 80%. So to avoid this, if any organization needs all their traffic to be inspected, but they can't have the firewall to run at high CPU, so they will deploy something called explicit proxy. So explicit proxy is something which you will configure in your browser. So like a pack file. So what will happen is you will configure a pack file in your PC, and on the firewall, you will configure an interface to listen to this explicit proxy. So what the pack file will do is, let's say you're trying to reach uh, fb.com and your connection will be on port 443. So this is what you want to reach. You are trying to reach from your browser. But what the pack file will do is instead of sending the connection on 443, the pack file will send the connection depending on the configuration on a different port, maybe port 8080. So your firewall interface will listen to connections coming on port 8080, and this traffic will be in plain text. So you will believe that you are sending your connection on port 443, but the pack file will not allow your browser to encrypt the connection. The pack file will send your connection in port 8080 on plain text. So when the traffic reaches your firewall, traffic will be in plain text. So it will check if it has to check for any if it has to perform any decryption. If yes, it will go through explicit proxy for decryption. Again, in depending on your pack file configuration, this plain text communication will happen. If your pack file is not configured to send the connection without encryption, then the firewall traffic can directly be sent to your inspection. But if your pack file is not capable, not configured to send the traffic in plain text, and if it's encrypted, then the firewall have to perform another decryption, and it will go through content inspection stage. So in content inspection, again, it's the same thing. IPS engine and your WAD engine will come in. So explicit proxy will be handled by WAD, and they will go through the same inspection process. So since this connection is not encrypted, it don't have to, not decrypted, it don't have to encrypt again. The packet is sent out, but this connection is decrypted, so it's encrypting and it's sending it out. So this is the only difference between the packet flow when it comes to explicit proxy and normal traffic flow. Now we have 10 minutes for Q&A. So let's use this time to answer any of your questions. Please feel free to unmute and ask the questions. And I will send this file, send a PDF file on our WhatsApp group. And if you get a chance, please read through the file for some better understanding.